In less than a year, we will witness a historic event that has never been done before by any space agency. NASA's OSIRIS-REx spacecraft will return to Earth with a sample of rocks and dust from a near-Earth asteroid called Bennu. This will be the first time that NASA has ever brought back an asteroid sample and only the second time in history that any space agency has done so. The first was Japan's Hayabusa mission, which returned a tiny amount of material from another asteroid, Itokawa, in 2010. But why are asteroid samples so important, and what can we expect to learn from them? In this video, we will answer these questions and more as we explore the fascinating world of asteroids and their role in the history and future of our solar system. Asteroids are rocky bodies that orbit the Sun, mostly between Mars and Jupiter. They are remnants of the early solar system when planets were forming out of a disk of dust and gas around the Sun. Some asteroids are as large as hundreds of kilometers across, while others are only a few meters in size. There are millions of asteroids in our solar system, and some of them occasionally cross paths with Earth. Asteroids are not only interesting for their scientific value, but also for their potential resources. Some asteroids contain metals, minerals, water, and organic compounds that could be useful for future exploration and colonization of space. Some asteroids may even hold clues to the origin of life on Earth and elsewhere. However, studying asteroids is not easy. They are very far away, very small, very dark, and very diverse. Only a few asteroids have been visited by spacecraft so far, and even fewer have been touched or sampled. Most of what we know about asteroids comes from observing them with telescopes or analyzing meteorites that fall to Earth. Meteorites are pieces of asteroids or other celestial bodies that survive the fiery entry through our atmosphere and land on our planet. They are valuable sources of information about the composition and history of asteroids, but they also have some limitations. For one thing, they are rare and hard to find. For another thing, they are often contaminated or altered by their exposure to Earth's environment. That's why sending a probe to a still-orbiting asteroid is the best way to collect a clean sample, and that's exactly what NASA's OSIRIS-REx mission did. Please give this video a thumbs up and subscribe to this channel for more videos before we proceed. Click the bell icon to receive notifications of new videos. Have you already done this? Let us start. History of asteroids on Earth. OSIRIS-REx stands for Origin Spectral Interpretation Resource Identification Security Regolith Explorer. It is a robotic spacecraft that was launched in 2016 with the goal of visiting an asteroid called Bennu, collecting a sample from its surface and returning it to Earth's for analysis. Bennu is a carbonaceous asteroid, which means it contains a lot of carbon and organic molecules. These are the building blocks of life as we know it. Carbonaceous asteroids are thought to be some of the oldest and most primitive objects in our solar system, dating back to more than 4 billion years ago. They may have delivered water or organic materials to Earth and other planets during their formation. Bennu is also a near-Earth asteroid, which means it has an orbit that brings it close to our planet every 6 years. Bennu is considered one of the most potentially hazardous asteroids known to exist. There is a small chance that it could collide with Earth in the late 22nd century, causing significant damage. OSIRIS-REx arrived at Bennu in 2018 and spent 2 years orbiting and mapping the asteroid in unprecedented detail. It was discovered that Bennu is a rugged world covered with boulders, craters, ridges, and grooves. It also found that Bennu is surprisingly active. It occasionally ejects small particles into space from its surface. In October 2020, OSIRIS-REx performed a daring maneuver. It briefly touched down on Bennu's surface with a robotic arm and used a blast of nitrogen gas to stir up some rocks and dust. It then captured some of this material in a sample container at the end of the arm. The mission team was thrilled to see that OSIRIS-REx had collected more than enough samples, about 300 grams, 10 ounces of material. That's the largest sample ever returned from an asteroid or any other small body in space. What might expect us? OSIRIS-REx is now on its way back to Earth, carrying the precious sample inside a capsule that will separate from the main spacecraft and enter our atmosphere on September 24, 2023. The capsule will have to withstand the intense heat and pressure of re-entry, as well as avoid any debris or weather that could interfere with its landing. The capsule is equipped with a heat shield and a parachute system that will slow it down and guide it to a designated landing site in the Utah desert. There, a team of NASA and Lockheed Martin personnel will be ready to recover the capsule and transport it to a temporary clean room, where they will check its condition and seal it in a container. The sample will then be flown to NASA's Johnson Space Center in Houston, Texas, where it will be unpacked and processed in a specially built laboratory. The curation team will carefully open the capsule and remove the sample container, which holds the rocks and dust collected from Bennu. They will also collect any material that may have escaped from the container during the flight of landing. The sample will be weighed, photographed, cataloged, and divided into smaller portions for distribution and analysis. Some of the samples will be reserved for future studies, while some will be shared with international partners who contributed to the mission. The rest will be available for scientists around the world to request and examine. What do we expect to learn from these samples? The OSIRIS-REx sample will be a treasure trove of information for researchers who want to learn more about asteroids and their role in our system. By studying the sample in laboratories on Earth, scientists will be able to use advanced instruments and techniques that are not possible on a spacecraft. Some of the questions that scientists hope to answer with the sample are: what is the exact composition and structure of Bennu's surface material? How much water and organic molecules does Bennu contain? How old is Bennu and how has it evolved over time? How does Bennu compare to other asteroids and meteorites? How does Bennu interact with solar radiation and micrometeoroids? What are the implications of Bennu's potential impact hazard for Earth? By answering these questions, scientists will gain new insights into the origin and evolution of our solar system, as well as the potential for life beyond Earth. They will also improve our understanding of how to explore and utilize asteroids for future missions. Why did NASA launch this mission in the first place? NASA launched OSIRIS-REx in 2016 with several objectives in mind. One was to advance our knowledge of asteroids and their connection to Earth. Another was to demonstrate new technologies and techniques for asteroid exploration and sample return. A third was to enhance our ability to protect Earth from potential asteroid impacts. OSIRIS-REx was not only a scientific mission, but also a technological one. It tested new instruments and sensors for asteroid characterization and navigation. It performed complex maneuvers such as orbiting, mapping, sampling, and escaping from a small body with low gravity. It also developed new protocols and procedures for handling and curating an extraterrestrial sample. OSIRIS-REx was also a mission with planetary defense implications. By studying Bennu's orbit, shape, mass, density, rotation, and surface features, thermal properties, and activity, OSIRIS-REx helped refine our models of how asteroids behave and respond to external forces. This information can help us predict how Bennu's orbit may change over time due to factors such as solar radiation pressure, gravitational interactions with other bodies, or even human intervention. OSIRIS-REx also contributed to NASA's Asteroid Redirect mission, ARM, which was a proposed mission to capture a small asteroid or boulder and bring it into lunar orbit for exploration by astronauts. Although ARM was cancelled in 2017, some of its technologies and concepts were incorporated into OSIRIS-REx. For example, OSIRIS-REx used a similar robotic arm and sampling mechanism as ARM. OSIRIS-REx also provided valuable data on how to approach, touch, and manipulate an asteroid surface. OSIRIS-REx is a groundbreaking mission that has achieved many firsts in space exploration. It has visited one of the most primitive and potentially hazardous asteroids in our vicinity. It has mapped its surface in unprecedented detail and observed its surprising activity. It has collected a large and pristine sample from its surface and is bringing back to Earth for analysis. Today's video has come to an end. Remember to give this video a thumbs up and subscribe to the channel to view more content. Remember to click the bell symbol to receive notifications when new videos are posted. I will leave you with this and hope to see you in the next video.